Welcome to part 2 of the Digital Dynamics Studio walkthrough tutorial. If you remember from part 1, we decided that we're going to do airflow past a cylinder in our example. So in part 1, we talked about the geometry involved, the size of the geometry, the boundary numbers, and boundary conditions that we'll use. So if you didn't see part 1, go back and review that. In this part 2, we're actually going to use the modeling tools of the Digital Dynamics Studio to actually create that model, make sure that the boundary numbers are assigned properly, and create the geometry and computational domain needed to do the simulation. If this is the first time you're using the tool, the modeling tool, this is what you're going to see. You get a default model, which we'll talk about in a moment, a few tools on the upper left. But basically, the entire browser here is your modeling workspace. So this is kind of the space where you're going to create your model and construct the geometry for your simulation. But let's talk about some of these tools on the upper left before we talk about the model itself. And both these can be opened, as you can see here. There's a menu which has some save, load, and other commands that we'll talk about in a moment. And on the left, we have the tools menu, which kind of hides and shows the editing tools, which again, we'll talk about in a moment after we kind of cover some basics. So as we said before, the entire display is basically your canvas for modeling. And there's a few ways you can manipulate that. Number one, you can kind of move things around like I'm doing here by just clicking the mouse anywhere in the view and moving it around. You can kind of move your model around. If you're on a tablet, you could just do that with your finger. Just touch the display and move it around with your finger. To zoom the model in and out, on a desktop, you can either hold the shift key down and move the mouse up and down like I'm doing here, or just use the middle mouse wheel and scroll that to zoom things in and out. Oftentimes, I can see here, you need to zoom out to see the entire domain. You know, we have a cylinder within a rectangle. This is your default model that you're going to get. If you're on a tablet, you can just pinch with 2 fingers to kind of zoom the view in and out, just using that pinching gesture on a tablet. As you move the mouse, you know, sometimes you move the model, sometimes you get the display in kind of a funky situation and you kind of want to put things back to the way they were. So at any time, you can hit the home key on your keyboard and it resets the view kind of to the default view. So you can do that if you need to reset things to where they were. Before we go further, let's talk about what is a model and what components make up the model. As you can see here, this is the default model you get. It's a cylinder within an outer domain of a rectangle. So everything you just see here, the 2 pieces here, that's your model. That's the entire model. And the models are constructed of components. So you can see here, this model has 2 components. It has the cylinder itself, which I'm highlighting right now, and the outer rectangle itself is another component, which I'm highlighting here. So you can see in this model there are 2 components. So models are constructed of a number of components. If I had more cylinders, each would be its own component. And if we zoom in here to a component, let's look at the cylinder a little more closely. You can see that the component itself is composed of curves. You can see that the cylinder is composed of 4 curves. As I select them, they're highlighted in red. And this outer rectangle is also composed of 4 curves. And you can select them, and each one is highlighted in red. Let's look at the cylinder a little more closely. And curves, so components are constructed from curves, and curves are constructed from points. So you can see here in gray, these are the points of the component, or of the curve itself. And you can select each one of those independently. You can see here that when you select a point, its coordinate is shown, as is the case when you select the center point of the component. With this little icon right here, its coordinate is shown as well. So you can see here that there are actually 2 types of curves, 2 types of points, 2 types of points. There's endpoints, which are the points at the ends of the curves, which I'm highlighting here. And then there are control points, which are these other points here that are kind of off into space. But you can see that the red dotted line, those are ultimately the tangent of the curve at the endpoint. So the line between this control point and this endpoint, this really defines the tangent of this curve at that endpoint. To manipulate the model at any time, you can just use the mouse to do it. Let's say, you can select the center point of the component, and as you move it around on the screen, the entire model moves. So you can move components around very easily with this technique. Same with the points. If you grab a point and just move it around, you can see that the shape of the curve changes based on the position of the point that you're moving around. So you can see it's very easy to kind of manipulate a model using these tools. You can see here the tangent vector. Like I said, these are tangent vectors, so they represent the tangent of the curve at the endpoint, so you can see how that plays a role as you move these control points around. One important thing to note, let's go over the tools here. One important thing to note about the tools is, let me talk about a couple of the commands, these undo and redo buttons right here. If you hover over any of these tools, a DILA description is provided to you along with the hotkey that might be associated with any of these commands. So that's a good way to quickly see what these tools do. But these are the undo and redo buttons. So if I push the undo, you can see that I'm undoing the manipulation that I previously did. And I can do redo to kind of reapply those. So you can see this is a very easy way to kind of, if you made a mistake or if you're just experimenting around, playing around, you can just undo those movements and go back to where you were before. I can move the component there and then undo it and it's back to where it was. Or redo it and kind of goes back to where it was before. So that's an easy way to kind of undo and redo any editing that you've done that you want to either get rid of or reapply. Let's talk about selection a bit. If you select the component, the center point of the component, the entire component is selected, as you can see here, highlighted in yellow. If you select a curve, the curve itself is selected, highlighted in red, whereas the other curves of the component are highlighted in yellow. And again, if you select a point, it is selected and shows the coordinate of the point. Same with you select the component center, its coordinate is provided for you. So a few other things you can do with the mouse with these models. We already showed that if you select the center point of the component, you can move it around. And same with the points, you can move those around by just selecting and dragging them. If you're on a tablet, you would just do that with your finger, of course. If you select a curve, you see that there's a point there where the curve is selected. And if you move that around, you rotate the component around. You can see in the center point, it's telling you that this current angle is 22.5 degrees in the negative direction, and the icon has changed. So this is the rotation mode if you just select a curve and rotate it. You can also see that when a curve is selected, you get these two little triangles, and those are for scale. You can select those, and you can see that the center is changed to a scale, and you can scale the object larger or smaller by using those triangles. Rotate by selecting on the point on the curve, or scale by moving the triangles up or down. And moving, of course, by just grabbing something and moving it around. Let me undo all that and put it back to the way it was. There we go. Okay, the next thing I want to talk about is grid snap. You can see as I move anything around, either the center of the component or a point, it kind of sticks to the grid. I can't move it. You can see I can't move it in the interior of the grid. That's because grid snap is enabled by this icon right here. And if I were to turn that off, then there's no restriction on how I can move this. Then you can see I can move it this point anywhere within the space. Same with the component itself. And same with rotation. The angles are any degree that I want. But if grid snap is enabled, it only lets you rotate at specific degrees. And grid snap is very important. Usually when you're making these models, you want things to be very precise. You need to create an exact cylinder or an exact square or exact cube or something. You need the coordinates to be very precise. And grid snap is a way to do that, to make sure that as you manipulate things, the new coordinates are very precise. You generally don't want arbitrary coordinates like we have here. Want 0.151 for the x and y, if 0.439. Normally you don't want that. You want very precise coordinates, so we can enable grid snap and then just move it to some exact coordinate that we want. So that's very important when you're manipulating your model. Another thing we want to talk about is boundaries. Remember in the part 1 of the tutorial, we talked about boundary numbers. And we can't see the boundary numbers assigned right now, but if we click on this icon right here, this eye icon, it'll show you the boundary numbers. So you can see that the cylinder, all the curves in the cylinder, assigned to boundary number 1. The left boundary is assigned to boundary number 2, the right boundary is assigned to boundary number 4, and the tops and bottoms are assigned to boundary number 3. Those are the default boundary assignments for these models. And if you ever want to change a boundary number, you just basically select the curve that you want to change the boundary number for, then go up to this icon right here, and you can change the boundary number to something else. Then if you were to select the link icon here on the right, then it basically assigns all the curves of the component to that same boundary number. It's just a shortcut to assign all the curves of a component to the same boundary number. But let's go back to boundary number 1 for this one right here. We're not going to talk about all these tools here. Other tutorials will cover these tools as well as the Digital Dynamics Studios documentation. But one other one I want to talk about is the numerical icon right here. So like we talk about when modeling, you want to be very precise in most cases. You want like the center of things to be exactly where you want them to be. You want the points to be exactly where you want them to be. Usually you can achieve that through grid snap and moving things around like this. But another way you can do it is with a numerical tool. At any time you can bring that up and you can type in exactly what coordinates you want, 0.123 for the x coordinate, 0.234 for the y component, and you see you get that exact component. And so that works with basically anything. You can do the angle. If I select this guide and do numerics, I can set the angle to, let's say, 33.3 degrees, and then I get exactly that angle. And points, of course. So you can select a point, numerically set its value, let's say -1, 2. You can exactly set a coordinate of anything. And the hotkey is just the N key on the keyboard. So if you type N, that same tool comes up and you can set exactly the value that you want. So this is a very useful tool, the numerical icon or the N hotkey. You can set exact coordinates of anything you want. So you can be very precise when you're making these models, which is important when you're doing a numerical simulation of something, that some device or some shape that you need to know exactly what, you need to define exactly what that shape should be. Let me do one here, undo here and go back to where we were before. The final thing we want to talk about is how do you save and load models. So that's in this menu here. We can open that up, save. So like any other application, you can save and reload models at any time. Maybe you want to, you're working on a model, it might take a little while, so you want to save it and then go back and work on it again later, or you want to load a model that you were previously working on and you want to continue editing it, or you're done, you want to save the model and you're going to reload it in the simulation tab to do your simulation. So that's what we have up here. You can push save at any time and save the model. Like anything, I'll give it a name, and it could be any descriptive name that you want, like test, model. You can also add a description if you want, used in the walkthrough tutorial. Anything that'll help you remember what this model is, what it's used for. You don't have to give a description, but you can if you want to. And then push save. So now it's saved, and I should note that this is a web application, so it's not saving it on your desktop or anything like that. It's just saving it internally within the browser itself, but it's persistent. So if you come back to this browser and load Digital Dynamics tomorrow, it'll be there. It won't be on a different browser or it won't be on a different computer, but within this, on this computer, on this browser, that model is saved. If you want to do a save as, there's no real save as command. Let's say I made some changes and I want to save this as my model. I can do save and just click on this model, reload its values and save, so that saved it under the same name. And you can see if I go back. Now if you want to load that model, you can just do load. And all the models that you have saved will be shown here right now. We only have one, but if I click on that model and load, it'll reload the model that I had before. Another feature to talk about is if you did want to download the model to your desktop, maybe you're going to share it with a friend or load it on a different computer or a different browser, you can, at any time, you can push the download button and it would download the model to your desktop in this kind of JSON file format. And then you can send that to someone else, another student, your your teacher, or reload it somewhere else anytime you want. You can push the download button. And conversely, of course, if you want to load that model anytime, you can push the upload button and then choose the model to upload and open it, and that model is reloaded into the system. So you have save, load, delete is if you want to just clean things up. You want to delete the model from memory, you just put delete at any time. And the other button up here is reset. This is the default cylinder setup, which you get by default. That if you do reset cylinder, that's what you're going to get. It's going to create a new model for your cylinder here. It actually create a new model. It looks the same, but it's a new model. You can also create a square, which is very similar, but has a square instead of a cylinder. You can do smooth square, which is similar, but has kind of rounded corners, you can see here. Or you can do airfoil. We're not going to talk about airfoils here, but you can play with it. In the documentation talks about airfoils as well as other tutorials, but you can create an airfoil geometry if you want and manipulate it. And the final one is just a box, and it is like kind of a default model, just for curves to help you get going on other models you might create in other use cases. Let's go back to our default cylinder model here. So that's a very high level overview of the modeling tab and the modeling tools. But the purpose of this tutorial is to create our model and setup for a simulation of airflow past the cylinder that we talked about in part 1. The good news is exactly what we talked about in part 1 is exactly how the default model is constructed. Boundary 1 is on the cylinder. Boundary 2 is this left inflow boundary. Boundary 3 is the tops and bottoms by default. And boundary 4 is the outflow boundary here on the right. If you remember from the part 1 of the tutorial, we wanted the radius to be 1.0 and the center to be at 0.0 of the cylinder. So if you click on the center point of the component, yes, that's 0.0 coordinate. And you click on any of these endpoints, you can see that yes, the radius is 1.0. So the size of the cylinder is a diameter of 2 and a radius of 1, which is what we want. We wanted the inflow boundary corner to be kind of a +10, -10, and yep, that's exactly the way we wanted it. We wanted the outflow boundary to be 30 units downstream, and yep, 30. So basically this model is exactly the way we want it to be, exactly as we described in part 1 of the tutorial. So this is actually set up properly, and this is what we want in the simulation. In part 3 of the walkthrough tutorial, we're going to load this model in the simulation tab and get things ready to perform the simulation of airflow past a cylinder using this model. So we'll see you there in part 3 of the tutorial, where we'll continue this to actually perform the simulation, or set up actually to perform the simulation of airflow past the cylinder using this model. So we'll see you there. Thank you.